Are we live? I think
Yes,
we're live.
live. Yeah.
Hello, everybody, and welcome to K6's office hours. One thing that may surprise you, or maybe not so much, it's the last one of the year. We are closing 2022. This, I don't know how if counted, but this season of office hours is going to be ending today. And to close it, we have today with us Marie Drake and Pablo Chacin. Hey guys, why don't you introduce yourselves?
Hello. So my name's Marie. I'm a DevRel here at K6, and I'll pass it over to Pablo quickly.
Hi, hello everybody. I'm Pablo. I'm the lead of the chaos engineering team in K6.
Excellent. Okay, so as you may have guessed, with Pablo's chaos engineering specialty, we will be talking a little bit about that. Probably the ones that joined know that the title for today is to talk about the disruptors. But before we jump into that, we have another small announcement that is also very big, very awesome, that we just did in the socials. But why not blasting out a little bit more here? Marie, bring it
Yeah.
on.
So yep, I'm just really excited to announce that we have formally launched our K6 Champions program. So it's something that we've been working here alongside the other DevRels for the past couple of months, and we're just really excited to have it like out there in the community. And we've had a few applications already, which is really positive. So if you're interested in sharing more to the community, even building your personal brand and collaborating more with the DevRel team, we have other like really awesome swags as well. I'm sure Leandro will sort you with those swags. But yes, if you're interested to join us as a K6 champion, I've added the link here so you can check it out at k6.io/champions hyphen program. You've got the application form in that landing page as well. Or if you just want to get if you just want to find out more about it, just feel free to reach out to myself, Leandro, or any other members of the K6 team, and we'll be happy to give you more information. So yeah, I'm just really excited that it's finally out there.
It's crazy. How many hours from the publishing until we started getting?
It's so this was actually like to those who like to anyone who doesn't know, this was my sort of official like first project when I joined K6, and that was just over 3 months ago. And I've accepted this as my first challenge, and I'm just really excited that yeah, it's out. I've had really a lot of awesome help from the team, so I couldn't really do it as well without everyone. So yeah, it's been an awesome 3 months.
Impressive.
Yeah.
And stay tuned because, as Marie very well mentioned, there's going to be some interesting swag with the champions to be very distinctive, that you shine out as a champion when you're walking around over the streets. But yeah, okay, enough with the announcements. I mean, we will close with a little bit more. We will shine out a little bit more on this. But now let's get to the beef of the talk today. So, Marie, why don't we start talking about what is this disruptor thing? Or
Yeah, I mean, I've heard about the XK6 disruptor during RocoCon. So, this was to anyone who doesn't know what RocoCon is. This is like our annual event at K6 where people are meeting in person for the first time, because here we are a remote first company. And I remember watching Pablo's talk about XK6 disruptor and how K6 can, help with chaos testing. So it's been a really interesting, topic to know, because I've heard about chaos testing, but I don't have like practical experiences with it. So it's really great that Pablo has joined us in today's office hours, so he can talk more about what XK6 Disruptor is, like what is like chaos testing, what is fault injection. So I'm actually gonna be passing this over to Pablo. And I think a question from my side, and maybe not just from my side, but from people who are watching, like what is like fault injection? Like why do we need to know about this?
Yeah, this is a great historic question because I think fall injection is something that probably most people have never heard about, even when it's a very well established practice, and I would say that's decades old. And it became popular again recently in the context of chaos testing, chaos engineering. So for many people, like fall injection and chaos engineering is the same, and actually it's not for many reasons. And I would really like to start like making a clear distinction between these two things. So fall injection is basically it's a technique where you test your system while you're injecting a predefined failure in the system. So, like you have a system and you say, okay, you want to really know how the system behaves when some specific, well-known, and controlled event happens, exceptional events. They can be whatever, and it can be applied to any system. Actually, there was a story I would say probably more related to even hardware failures. So you can do it with components, and you can actually say, okay, what's happening if I disconnect this physically, for instance? That's full injection. You're injecting a fault in the system. So that's the basic technique. Just testing your system under a specific fault that you are injecting and controlling.
It
Um,
is.
now,
I just wanted to jump in because it is very. I think it's crucial what you're making a distinction, because many times when people hear about chaos testing, and probably what they've heard is about the chaos monkey and Netflix's first steps, and we have often I did at the very beginning. I remember chaos engineering. Okay, you just leave something that randomly starts shutting on and off all over the place, and it's not so chaotic, right?
well, actually, that's the point. It is. I mean, chaos engineering is that, but the point is that fall injection and what we are now calling chaos testing, just to make a difference. And chaos engineering is like a different practices around a spectrum that depends on where your objectives are. It's like um, if you know your system should be resilient to specific failures because it's part of the specification. You know, for instance, it's very common in some what is called safety critical system like automotive avionics. You have a specification that your system should survive to specific and be resilient to specific failures. So that's part of the specification of the system. So it's not chaotic because you know it. It's really say you should survive if you have, for instance, in avionics, it's very common that you have multiple components and redundancy. Say you should survive to half of the component failing, and the plane should still be flying because you don't want it to drop. So you need to test that. So it's not chaotic. It's because you really know as part of the specification. In order to test, you need to inject it for. So that's where I say like a fall injection is a technique of testing your system under specific failures, and then you can use it for different purposes. And one spectrum, end of the spectrum is this one when you have the specification, and the other end of the spectrum is chaos engineering. Why? Because as the system become more and more complex, and then you can imagine nowadays the infrastructure is complex for many different reasons. You have many different layers. You have your cloud, and then has your Kubernetes cluster, and has your application, which is a distributed application, is microservices, and you have a lot of stuff. And at some point, you really don't know how this system is going to behave anymore because it's not only that it has so many different components, also any one of these components has its own mechanism for resilience, some kind of feedback loops that try to recover to failure. So if you, for instance, go to the cluster, your infrastructure, you disconnect a physical node, it's really hard to predict what's going to happen. If someone tells you, I know, it's probably lying. You know, you had a guess, but you don't really know because it depends on a lot of factors. So this is the context in which chaos engineering arises. Like we need to really make experiments because you need to learn. And the other spectrum is I have a specification, I need to verify that I pass that. So
Mm.
you see, it's completely opposite way. You something which is predefined and something that is experiment. That's why I really like in the chaos engineering community they use the term experiment and not test because you're really not testing, you're experimenting, you're trying to figure it out and make hypotheses and say, well, let's see how this behave, and then you basically want to learn about what is called the failure mode of your system, how your system fails. Once you know that, then you can test your system under those failures because you know. And this is how the disruptor, the idea of the disruptor came. It's like um, after you have an incident that you have the failure in the system, you learn. You say, okay, we had this incident, and when this happened, this database was overloaded. We noticed that this microservice was really having a very high latency, and suddenly we noticed that each of the service that depends on this one has this strange behavior. So you learn that, and then you need the next step is you need to test how to make your system resilient to that. You see, you pass from the experiment when you learn to now you need to test your system and say you need to be able to reproduce what you saw. Okay, and here's where we are diverging a little bit from the chaos engineering. Is we don't want to reproduce the original failure that happened. We want
Mm.
to reproduce how this affected your application, and then I want to test your application reproducing these failures. You see, and test it.
And
You want to test it because you want to really see how resilient it is, or you want to try different strategies to make your application more resilient. You see, so you're shifting your focus from learning to applying what you learned to make your application more resilient to failures. And that's basically the mindset in which we are thinking in the disruptor.
you're doing there a very good distinction on experiments because again, my feeling is that on chaos engineering and all that area, you think that it's the focus of randomly start moving things, but no. Generally, you are very focused on a particular situation that you want to see how it will affect, and to inject that situation. That's what you're trying to do. These fault injections. And I got curious and also wanted to share with the audience what are some examples of this type of faults that you can inject, that situations, a few examples so that people are aware what can be added?
That's again a difference between what we're doing with the injector, the rupture, and the chaos engineering. Is like the chaos engineering community mostly revolves around people working in platforms.
Hmm.
So what they are trying to do is to inject failures in the platforms. Okay, for instance, disrupting a physical node on a network and creating some situation where part of the infrastructure is being affected. But for most of the again, this is important because this infrastructure is really complex and you don't really can predict all that. But suppose that you have this situation, you inject this in this failure in a node, you basically overload the node where a database is running, and you simulate that the CPU is too high because whatever reason. And when this happened, then in this experiment that you learned, you observe that this situation will create some effects in other applications. Like for instance, a latency is going to be high, or the error rate will rise. Okay, and that's where we take this situation and say, okay, now, and probably it will be easier to explain that if we can share this image that we have in the blog where we describe that probably, because this is a blog that we publish with the disruptor that is how you can do chaos testing with a microservice application using the disruptor, and precisely we describe this situation where we have this complex application that has many microservices. And the situation that I'm describing before is, for instance, if you have this catalog service that has a database, and for whatever reason this database is overloaded, and then you are the responsible for the front end microservice, and then you say, okay, how will the front end behave when this database is overloaded? What we have noticed is that there is an increase in the latency over like for X milliseconds, and also we start having a higher rate of failure because at some point the catalog service can no longer respond. That's something that you learn for either a chaos engineering experiment or because it's a real failure that you experiment, an incident that you have. So the idea here is that we can now go and we'll browse down, and then okay, let's test it. Let's do this following. Let's create a test when we inject load in the front end service while we reproduce in the catalog. We inject values in the catalog so that the front end will experiment the same pattern of failure, a higher latency, some random uh, 500 errors in the response from the request. So what you're doing now is you're reproducing how this front end service experiments the failure. You see, the incident that you previously experienced. That will allow you to really test and say, okay, how this application behave, and then you can probably improve the resilience of this application because you can reproduce it. And this is interesting because you don't need to go back and overload the database or make that other like heavy experiment again. You say, okay, I know that what I will see in the front end is that the catalog is running much slower. So basically, the idea is that that's the kind of fault that you inject here in the catalog. And this is interesting because you're actually testing one service where you're injecting the fault in a dependency of this service. I don't know if that
And
makes sense, but it's probably like trying just as a developer, you don't want to really get involved in the complexity of reproducing the original incident. They can be really complex. And that's actually how this came. This is how I landed in this idea was because I was in my previous job, I was at SRE. I was helping teams to improve the resilience of their application. And one of the problems we had was after the incident, we came to some conclusion that we should try to make the application more robust to certain situations. But how do you reproduce that? It's just too heavy. It's do you really want to go and install a database and on a node, and then you have so many dependencies, and you need to simulate. And sometimes you try to simulate this incident, and this because of the complexity of the system, it's not really that easy to reproduce them.
That actually leads to my next question, because I'm guessing let's say like typical teams, who wants to get started with like chaos testing, um obviously like our whole talk would be about introducing XK6 disruptor, but like if someone wants to get started with chaos testing using like other tools, is it quite common that it's quite difficult to get started with? Because I'm guessing there's a lot of like varying components that we need to have like this chaos experiment like to start over. So I guess my question is, from your experience, how difficult or how easy it is for companies to start doing chaos testing?
Well, that's the objective of this project is actually to make it easier because my experience was precisely that there was like a huge gap between
Mhm.
the people who should be testing, which are developers or the responsible, and the people who was actually able to reproduce it. And I want to insist in this is the typical situation as an SRE or DevOps or infra people that you had this incident and you have so many different root cause or possible root cause that the database was overloaded, but it happened that you try to reproduce it overload again in the database, you may end up with a different fault because it's really hard to control that complex systems.
Yeah.
So that's why what is important to make experiments, because you need to learn. But once you learn, reproducing, and that's what testing is. Because for me, testing is only valid you can reproduce the situation and validate it.
It should be controlled. Yes.
Otherwise, it's like you don't have control of your test. So that's what we intended to do, was to create a tool that allows you to test applications under a simulated fault without all the complexity of setting up and reproducing an actual incident in an actual infrastructure. As you can see here, you are actually just running your application, but how it works. It's probably interesting to make it more to make it more um, clear. Is that the disruptor is basically it's an extension of cases, so it's you just solo part of the cases, and when what it basically does is the disruptor has is an API that offer a set of disruptor. Each disruptor has a target. Okay, for instance, you can disrupt bots, or you can disrupt a service in a Kubernetes. In this point, we are basically focused on Kubernetes environments for different reasons. So when you create a disruptor, what the extension will do is that it will go to the target. Say you want to disrupt probably the service is better because it's simpler. That you want to disrupt a service in your Kubernetes cluster. So you basically create a service disruptor, and the service disruptor basically will go to the cluster, will see which are the bots that are back in the service, and it will inject an agent. Okay, so you go here. The detail is we basically now on every one of the bots that you want to disrupt, there is a component that is installed by the disruptor directly in the bot. So do you really need to install anything? It's just you create a new container that is what they call a sidecar container. You inject it, and now it is part of your bot. And then you can instruct this agent to disrupt this bot. For instance, when you're injecting HTTP failure, that what we are implementing now, it basically will trap all the traffic and will inject failures. Or if you want it to delay the request, it will introduce an artificial delay. And that's it. So you don't need to install any other component. You don't need to actually, it only will disrupt this service while you are running the test. So when the test is over, your application runs as normal. So,
And one interesting distinction as well. What you're mentioning, that the disruptor lets you control how much is the system slowed down or affected, because that's another one that generally what we think of these experiments is just turning on and off services, servers or components, which is not the case. It is, as you very well said, you need to control precisely to replicate what happened in a given circumstance or a specific situation that you want to do the experiment for, and be able to repeat it. You try to apply a fix, then you want to see again exactly the same thing. That if you, I think you let it to the database, as you very well said, to okay, it's going to slow down. Probably it won't slow down. Someone else fixed the index or something like that, and it's going to be not so replicable to see if what you tried worked. And so something that pops out in my mind, you mentioned that there's no need to actually install an agent, because you need to have some control on these components that are going to be affected in your experiment. And other than slowness, what else would you say the disruptor can affect or modify?
well, what I said before, that you need to install another component, because the model that other tools use is that you need to install a operator or some complex tool that, to be honest, sometimes is overkill. You just to test something, because you need to maintain. Like um, in this case, you have your application and you want to run the test, and during the test, the router will install these agents, because you actually need some component in your target that actually inject default. But this is not need to maintain. It's like you run the test and you are done. Okay, and this agent is basically can inject any kind of failures potentially. We initially focus, and now in this initial version, uh, we're focusing on HTTP request failures because in most microservice applications that covers like 90% of the failures. What you mostly will experience are either slowness or eventually some return code at 500 or something like that that tells you the other end is not responding. Okay. The interesting here is that you don't really need to wonder why this happened. It's just you know it will happen and you replicate it. See, you don't need to replicate, and the other tools are more complicated, saying that, oh, I want to slow down the database because I want to. No, no, no. Forget about it. You want to slow down the API? Boom. Your API now is slower for whatever reason. And interestingly, it will cover either that the database is overload or the CPU is overload or you have a memory issue. You don't really care because if you are, again, you are the guy, the person who is in the phone who is in the front end service, you don't really care what's happening in your dependency. What you care is what you're observing. And you will observe basically either of these two things, slowness or failures. I mean,
which
return code are not.
I would say both of them translate pretty much into slowness. I mean, when you get a failure, the slowness is infinite. You just don't get a
Yeah,
response.
absolutely, absolutely. That's actually I can't remember who, but someone in the community once said that basically everything becomes a slowness. What is
Mm.
happening is some points, some components are smarter than that and tell you, hey, guy,
Time out.
500, I'm no longer available. Like,
Hmm.
don't call me, I will call you back, and and you can also simulate that. And that is and this is where we are focusing on that. That said, we are also working and implementing other kind of failures that are all important. Like for instance, for other kind of services, um, for instance, if you are experiencing, sometimes you are depends on the, for instance, database. You want to see what's happening is you start having connection dropping because you maintain a pool of connections. HTTP is kind of resilient to connection failure, but other protocols are not that so. So you have a connection pool to backend, a database, and these connections start dropping for whatever reason. You need to really know you are handling this failure correctly. And that's another failure that we're going to introduce in the near future, for instance. But again, I think that are perceived by the application. We don't want to get into reproducing the root cause of this. I don't care why the database is dropping connection. There's another problem. My problem is, as a developer, I want to test my application when that happens.
How
And
that situation impacts
that's and
our
be
elements.
able to reproduce it, because if you are saying, okay, we need to improve, and this is a real case that I experienced. So someone that created a connection pool to the database. For historical reason, they create their own connection pool manager. And then we had this incident when they have a problem with the connection pool. And then the problem was, okay, we have a bug. We think we solve it. How do you test it? How do you force the database to drop connection? That's not trivial situation. So we were like, okay, let's wait for the next incident. If the next
Oh,
time,
and I may jump in here because it's something that at times many teams will think that we are the SREs, chaos engineers, or we're responsible for finding or tuning or those external situations that bring chaos into our project, our software. And to give a very quick example, I have experienced some of that as well. And it was related to a database that was a database by a third-party provider. We didn't even have control, access. We didn't, but we depended on it. And we needed to control or be able to fine-tune our application into guaranteeing that in the end is resilience what we want to imbue into our applications. Those distinctions are, I think, very important to be understood because many times team members, management, or even the same team won't be so aware about it. And but Speaking on distinctions, Marie, I think we have a
Yeah,
comment about that.
we actually do have a question from one of our viewers in our YouTube channel. So Rodrigo asks if chaos testing and DR, which is disaster recovery, if they are the same or disaster recovery is another kind of chaos testing.
Well, that's an interesting question. I think that disaster recovery
I
is really
may add,
spelled. It's
he
really spelled.
mentioned
Yep.
disaster recovery testing, which
Mhm.
is an interesting.
Yeah, disaster recovery testing for me again it's different from chaos testing in the sense that and I have some experience with that because at the beginning of my career I worked in a data center, in a mainframe data center, and actually I was one of the sysadmins. So we actually need to go through this that disaster recovery planning and basically again um, you you have a plan, so you being that you are prepared for and you test specific failures.
I
And
think
you basically, what you are testing is that your runbook works for that situation or not. So I would say this is really something more control. Again, for me, chaos testing is more, or chaos engineering in general is more like learning. Again, for me, is the focus in chaos engineering and chaos testing is learning more about the failure modes. And once you learn, then you need to do all the other work, which is depending on your objective. Is in the case of application, you want to make it more resilient to the situation that you have learned that happens, as we said it before. You learn that when the database is overloaded, you have an increase in 500 responses, and the time, the response time grows to X seconds. That's something you learn, and then you need to do something with that. And that's something that you need to do. As whatever you decide to do, you need to test it.
I think
It's
there
like a
a
cycle that you learn and you improve and you learn and you improve. So it's not either or. It's like for me is you should be keep doing chaos engineering because you need to learn more about your system. As your system evolve, you need to keep your failure. This is the name of that is the failure mode. So you make your model of how the system fails. You need to understand that. And for that kind of failure, you need to develop responses. And disaster recovery basically happens when you want to really. Disaster recovery basically with the situation when you are not able to maintain the business working anymore. Um, so it's like an extreme case, like for instance, your data center burns out. That happened to a cloud provider in France last year. You just burn out. The whole data center was burned. So you need a disaster recovery because you need to measure to maintain the business operating. But for me, this is a completely different scenario because it's not only application technology. Sometimes you need to consider things like to move your people. For instance, in the bank where I work, we have a place that we have an arrangement that in case of a disaster, we can move the people physically there because we were preparing for the contingency of a fire in our building. So you need to have a physical place to people to work.
I
It's not
think
only keeping your system working, it's that you don't have a place, you don't have a house anymore. So that's for me, it's a different scope of what we're talking. We're talking more like the typical failure that happen in your infrastructure. You need to keep your application, your system running. But your business is not being threatened by this situation.
I can do an analogy there with performance testing, where in testing, performance testing, we're just finding out where are the problems, and there's an after practice that is the optimization phase, where you say, hey, do I need to better my programming, do I need tuning, do I need, but that's not specifically part of the testing. And to give a background, when I was a consultant, we had like a saying, you are testing it, you are not offering solutions nor fixes. That's for the devs, the DBAs, network infrastructure, everyone. And I think the disaster recovery distinction is when you already have a path of action for when a disaster happens, and you're testing how well that works. With chaos testing, you probably don't even have that route of action. You're saying like, hey, this may happen, this already happened, how the impact will be. Because to my personal and external, very non-respectable opinion, is something that you are figuring out with chaos. And with disaster recovery, you already have a plan, a contingency plan, and you want to see how good that is. So may seem like they are linked, but most probably they are separate practices, items. Not saying that there won't be collaboration and talk to the teams among with these
Goes
situations,
hand in hand. Yeah.
but they go in hand in hand. Yeah,
Yeah, you can think that like disaster recovery, as you said, is what happened after you learn from incidents that are a certain scope, and you can actually use some chaos engineering techniques for actually learning about your system. Um, what I would say is that disaster recovery, by disaster, like you get the terminology, but usually in the community that practice disaster recovery, usually uh, the 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 assumption is that whatever happened is putting your business at risk. It's like it's not just that you have a service that is out there. It's like what happens. I said the data center is totally destroyed,
that's a very good
or,
point
or or
because
or you lost, or your ransomware attack. Nowadays, for instance, ransomware like, is probably the biggest threat that any business has. Business recovery plan is how do you know if all my infrastructure is suddenly locked? I don't even have
it's
access to my backups. What you do, you basically are rising this to the level of only technology but also business. It's like you need to consider other aspects like people and business relationships and a lot of stuff. So it's like a chain of not a chain, but a different scale
that's a
of
very good
problems.
distinction because disaster recovery has to be something catastrophic or something that is a big impact. And with chaos engineering, you may just wanting to do the experiment. What happens if this component gets a little bit slow? What is going to be the impact over here? Disaster recovery is like the whole site is down, the data center, as you said, the tables were dropped, or things that sound to me a little bit more intense. And with chaos, we can be doing experiments that are not intense at all, just to see what is going to be the affection and
I
repeat.
say usually don't involve the business part. I want to recall
Mm,
that in the disaster recovery, you usually need to involve the business because actually the hypothesis that you have in disaster recovery that your business is no longer able to work. So you have consider even legal uh, consideration, like you are liable for not being able to fulfill some, services.
data breach.
It's a really interesting word, by the way, but it's kind of the different spectrum that no word we are talking. Bringing back a little bit to our context is like we're more in the realm of failure in components of an infrastructure or an application, and how as a developer, and you mentioned that before, I think, Andrew, that as a developer, not as an infra person, not like a SRE, but just as a person who is responsible for a systems that have experienced certain failures, and you need to be able to reproduce the situation and be sure, and that's where the part of testing is can be reproducible and predictable, and then you can test. You can see if you are actually um, handling the situation in a way that you can maintain it's satisfactory for your customer. That's
It's
basically the content of this, and I think this is important because, to be honest, I don't think there are many tools out there that allow you to do that. Unfortunately, the focus has been too much in the infrastructure side, but it's like they say that there you can as a developer, but to be honest, I, after the SRE and a platform person, sometimes I see only the structure for installing something. And look at what really. The other day I was sharing with some folks in the team the structure for installing one of these chaos tools. I was just scrolling. It was like 20 pages of installation, just installing. And I'm an infra person, and I would say like really do
Mhm.
that? I did do that. I usually only want to test how my application, what's happened to my application if the latency goes to 3 seconds. You're telling me I need to install this and that and create out of the after permission in the cluster. And then the blast radio. The other thing is the blast radio. It's like, okay, let's imagine you want to crowd test it now. Let's disconnect the no. Well,
That
you're
has to do a
probably
little bit with the
making
control,
promises.
right?
Your blessed radio is probably precisely the chaos. You
Hmm.
probably want to test something that you are not testing something different because you're creating some side effects that you are not really expecting to happen. So one of the advantages of the or approach is that you are only introducing what you're saying and nothing else. If you're saying the request for this specific service is going to be 100 milliseconds, that's not going to happen. There is nothing else. You don't see other services failing. You don't see suddenly, because if you shut down the server and for whatever reason the system tries to recover, you will experience a lot of overhead in the network because the system is trying to recover. All that happens. That's why chaos is important. Because if you're testing something, you don't want to get messed on this side effect that you don't control. So here is no, I want to just to test this. This is
I guess
that.
that's the real beauty as well of the other use cases for K6, because we've already positioned ourselves as the best developer experience for performance and load testing, and it's really awesome to see how we're trying to make all these chaos testing fault injection as simpler as possible. So because we're trying to promote the mindset of it shouldn't just be the tester's responsibility, or it shouldn't just be another team's responsibility, but if you're just interested in trying to make your systems reliable, then we should be able to provide a tool that will provide like a simpler way of doing things. So it's really interested to see that, yeah, we're trying to address that. There is a question, Pablo, that I hope you can try to answer. So I think a while ago you were showing the diagram with injecting faults into pods or services, and Kale is asking if you can also inject faults. Like I guess in the node perspective. So for example, if pods are running on node, can we also inject faults into that?
That's definitely in the roadmap. If you go to the Git repository for the project, you will see we have a roadmap. And one of the things we are going to develop in the next month is precisely one of the next things. It's actually something that we even have a proof of concept for that, but we
Nice.
wanted to kind of have a really focus first in one. It's more like having one of the failures well, done and then move to the next one instead of having many of them that are different. So this is actually something that we plan to do very soon. I would say in the first quarter next year for sure, because we will have a proof of concept. To be honest, this is kind of easy to do because the tricky part is that for us was like for the HTTP injection is to make this work. You need to basically put the component inside a running pod and then rewire the TCP connections and make the traffic pass. It's a lot more complicated than running something in a node and forcing some situation there. And we have tried that, tested that, and we know we can do it. And we are going to implement it very soon. So we are adding this node disruptor as one of the. And basically, the idea you will be able to inject a load like consumer resources and memory or CPU, and also inject failures in the network, like even disconnecting the network, the node from the network, and that kind of situation. So that's definitely something we are planning to do. Um, that said, I think that is because we are going to target another public. It's more like DevOps and SREs and people that really their business, their responsibility is being sure that the platform can survive to that kind of situations. So that's also why we are like creating. We want to create tools that work for a specific audience, and giving the best experience for any one of them. And that's definitely the roadmap. That said, for the way I was talking about how easy it is to inject the form, but I haven't shown people how it's done.
Yeah, that would be really awesome if you can show
Yeah,
us a really exciting demo.
Real
yeah. We
life
have here
example.
this.
That would be
We have
awesome.
in the documentation. We have an example of how to inject an HTTP form in the pod, right? And I will go to all the code. This is really simple code. I mean, this I'm showing is all the code. But the interesting part is this one. Sorry for the scrolling. This one. This is all that you need to inject a form in a. Let me try to maybe make it a little bit bigger. This is basically this snip of code. You are basically creating what is called a selector. You're saying which pod you want to target. For instance, you select all the pod that match a certain label. You create a pod disruptor. You define a fault. You say, I want to inject a delay of 50 milliseconds and an error rate of 10%. That is, 10% of the request will return this code, the 500, and then you inject the fault, and that's all you need. And that will guarantee you that every time you run this test, you will inject this failure and the result will be predictable. And And you can, the interesting part is that you can use it with an existing test. That's another thing that's interesting, that you already have a load test or a functional test that you are using for your system. You can just add the failures on top of that test. You don't need to create a different test or you don't need to create a different setup. You can actually just compare. You say, okay, I will run this test with and without failures and see how it changed. And you can actually, we have time. I think we have time. We can. I have the deployment of this example. In this example, we are basically giving all the code, and you can actually download all the description and all the the specific the instruction for setting that in your local cluster. Pretty, you have a test cluster, and basically you run it. While we're running this. Uh, um, we make this trick that the code you will see that we have a conditional statement that depending on this environment variable it will uh, skip the test or not at the failure or not. So you can run it. I'm gonna run it, and then that should be the normal execution. Okay, and it's like 30 seconds. And then you will see that we can just repeat it. The idea is that one of the things that we wanted to do in this example is that offer some ideas to the people, best practice or practice that they can use to easily reuse existing tests and not need to create a specific test for failure or for chaos. You just have a set of predefined tests. Okay, you see here it works. You have zero errors, and you have a certain
Pablo, do you mind zooming in a little bit?
oh, yep. Uh, is that right?
I hope so.
Yeah, looks good to me.
Okay. And you see that here you have zero errors, and the average latency is 100 milliseconds. Okay. Basically, the test what it is doing is some simple HTTP request to a pod that is deployed in this cluster. And now, if I just repeat this test, I say, okay, now I want to actually um, inject the test at the failures. The first thing you notice is that it's an error because we are rewiring the TCP connections, and that is normal. That is not a problem. That basically shows that the agent was injected in the pod and it was playing with the TCP connection. So you sometimes will see this warning, but this is expected. And then you will see take a 30. The reason that 30 seconds is because otherwise, okay. And now you see that you have almost 10% of failures in the test. And you see the latency grow by what is expected. As you see here, the definition of the failure was precisely um, 10% of error rates and an average delay of 50 seconds on top of what is normal. So you can see that as you compare the results, now the latency, the average is average is much higher, is 150, where before it was 100. And you can
And
get a precise number of errors, so you really know what you are testing. And every time you run it, if I run this test 10 times, you will get almost approximately the same results every time.
something that I saw that you did, this was two separate different runs. I'm guessing that if you have a slightly longer execution, can you inject halfway there some disruption at the middle of the
Yeah,
test so that you can
absolutely,
see?
absolutely. That's something you can do. Actually, going a little bit more into the detail of how we actually inject the failures. I explained this is the function that inject the failure. What you usually would do is sorry. What we usually do is to create different scenarios. Okay, and you can. This is a scenario is the one that inject. You can, for instance, run the load for 5 minutes or 2 minutes, and then to say, I will inject the failure after 30 seconds, and then I will inject failure for 30 seconds. So you can have a scenario that you at the middle you will inject it. That's why you usually the practice that you will have a different scenario that you can control when it starts, okay, at what point. In this case, it's a simple case where you're just running the whole test. Um,
Mhm.
one of the reasons is because it's easier to compare. Because
No, and what I was foreseeing, some integration with Grafana, having a live dashboard where we can see how it is going, and boom, here is the disruption, and you can see how everything is affected, the spike on errors, and
absolutely,
some of these
absolutely,
things
absolutely,
live.
that's something you can do. And actually, the reason we are not doing that way because we don't want here in this, let's say, initial contact with the content introduce so many different moving parts, but also because sometimes if you want to test, I personally for the testing
That
perspective,
remains
I
to
would personally
the blast
prefer.
radius, right?
Sorry.
Not that refers to the blast radius part that we were mentioning, to not to have that many moving parts. You want to control a little bit the test better, right?
Yeah, no, and also moving part in the sense that for a test as a tester, you need to rely on watching something in a in a in a dashboard. See, here we can use something like, for instance, you have this test and you have all the nice thing here is that we are like um, native in the cases programming models that you have your tests and you have your checks and you have, for
Hmm.
instance, you see the other example that we're showing the blog. We actually here we use um, we define checks for the error. So you can do all this. And what I'm saying that it's very easy to have a test that even it's an existing one. Listen to that, you already have this, and you with a very few changes, you just describe, okay, I want to run this baseline and rerun it with failures, and then you have to run, and you can see if
There's another functionality with what you're saying, with having two separate tests that you can overlap them and see what is the difference one to the other, which is also useful. I mean, and that's a cool thing that you can do lots of mixes integrated, as you say, try to not to go too crazy or put too many things. But speaking of integrations, I had that question. What else can XK6 disruptor be integrated with? What other extensions with K6 can we play together?
what one of the things that we see that is a, I would say, perfect match, and we are really excited is the browser station because um, it's interesting to see that many of these failures how they affect the front end. I mean, this user experience is really sometimes, I won't say unpredictable, but it's complex because you see this page, the page in the background is making a lot of requests. So it's not easy to predict if my response time right from 100 milliseconds to 500 milliseconds, how the experience is going to be. It's going to experience what the actual load time for the page. Sometimes you cannot make this math very easily because you really need to test it, and then you can use the browser to really see that. And one of the things that we noticed, for instance, when we're making this demo, is that this particular demo application is a demo application, it's not a real application. But what's interesting that when we injected some failures, the front end didn't notice that. And then you had pages that were blank. And there was absolutely nothing that said, oh, we could not load the catalog. Nothing. You just load the page and there was some missing information. I was like,
There are some
why
examples
is it
that I
not
have
working? What was
seen.
it? You should be saying, telling me, I can now show the product, please retry or whatever.
Sometimes some things that we will see from the protocol perspective with standard K6 script won't deal that much as an example with JavaScript, style sheets, images, that if there's something slowing down, let's say on your CDN or where you are storing some of these elements, the front end will notice it. And if you're inserting some disruption on some of those, that slows down the user experience, even if your K6 scripts at the protocol level say that everything is fine. So yeah, there are so many mixes with Disruptor and K6 browser that you will notice right away. And usually that's the end step, right? That the user doesn't get it, and where can we get disaffection, right? But looking at the time, I think we should be getting into the ramp down section. But there was another question, Mary. I think you were going to ask.
I think no, we've answered most of the questions from the chat. I guess just from my side, especially that Pablo has mentioned the XK6 browser stuff. I think it would be really great to have that working example to see how both XK6 browser and XK6 disruptor works. So maybe that's something that maybe Pablo and I can like collaborate with and then showcase it in one of the episode, because I think at the end it's all about that user experience. So if we can catch it from the browser and see what's happening while one of the services are being disrupted, that would be a really like great use case. In terms of other future plans, Pablo, so you mentioned that there will be support for nodes. I know we've got a few extensions already that are part of the experimental module in K6. So do you also like, do we also have plans to have XK6 disruptor part as an experimental module? And are there any other future plans that you would like to share to our community?
Well, most of the plan is already described in the roadmap that I mentioned, but I see the focus now is in three areas. The first one, it is the first release that we make, is this 0.1. I mean, you can use it, please use it only in test or staging environment. It's not production ready for several reasons. So we need basically hardware because we don't want to, we want to be really sure that if you try this in a, or use it in a production environment, it won't actually, once the test is over, there is no side effects or anything like that. So that's one of the focus. So we are working on improving the reliability of the disruptor itself. The second is growing the number of failures or faults that we can inject, and also the target. Like for instance, the node disruptor. That's something which is going to come in the next in the first quarter next year, and some additional failure for pods. As I mentioned, the connection failures. I think it's interesting because it's something that you experience a lot. Another one which is also easy to implement and probably actually something that is someone want to collaborate with the project is a very good starting point is killing pods. Killing pods is really easy, and also have a proof of concept of that. So that's something that's going to come in anytime soon. To be honest, is use it for from very specific use cases. That's why we don't really introduce it in the initial release. And that's basically the plan. Like regarding the other point that you mentioned, the making experiment, I think that we need to make it more reliable. I mean, have more tested, battle tests a lot more. So we are, for instance, also started to use it internally in cases of dog fooding. So we want to also other teams inside the Grafana company to start using it. So probably that will be one of the focus in the next quarter also. So we get more confidence on the extension before we plan to make it part of the
Cool.
core cases.
Awesome.
Cool. And I think that's it. Our time is up. But yeah, I just want to say thank you, Pablo, for sharing a lot of insights about the XK6 Disruptor. Again, we do need a lot of feedback as well from the community. So I've added the GitHub project link. So if you want to try it out, play around with it. If you find any issues, raise it in the GitHub project. And I hope you enjoyed our K6 episode today. And as Leandro mentioned, we'll be back next year. So this is our final episode of this year.
And before we log off, don't forget K6 Champions. The program is already on. You can take a look, check it. If you're interested, if you know someone that may be interested as well, stay tuned with the champions, with Disruptor, K6 Browser, everything that we have been doing all over the year. And with that, I would say happy holidays, everyone. Feliz Navidad here. And take care, and thank you for joining us all this year. Full of fun here.
Thank you. Bye
Thank
bye.
you.
Take
Bye
care,
bye.
everyone. Adios.